in this video, we're going to be solving a series of JAMB likely examination questions in physics. Okay, now before I start attempting these questions on the board, those persons writing the JAMB examination, I want you guys to go down to the comment section and comment JAMB exam, just so that I know you're writing the examination and we can stay connected. Okay, now the first question on the board reads: a copper cube weighs 0.25 Newton in air, 0.17 Newton when immersed completely, okay, in paraffin oil, and 0.15 Newton when completely immersed in water. The ratio of ruptures in oil to ruptures in water is, now this is quite an easy question. Okay, now JAMB knows what they are doing, that's why they are giving a question like this. Okay, first things first, you need to understand what ruptures is. Now whenever an object is immersed in a fluid, okay, whenever an object is immersed in a fluid, there's always an upward force. Now that upward force is what we call what now? Ruptures. Okay, the force will always act up now vertically upward, and we call that force what now? Ruptures. Mind you, the weight of the body is always there. Now it is different from what it is in air than what it is in the fluid, which means we are trying to say if this object is immersed in water or in any other fluid, it is going to have a different weight whenever you measure it inside of the fluid. Okay, now what you must know is that whenever we sum up the ruptures in that fluid, okay, that is acting on that object that is being immersed, okay, and the weight inside of the fluid, it is going to equal the weight of the objects in air. It's always true. Okay, I'm trying to say that whenever we sum up the ruptures, okay, and the weight inside of a fluid, you get what now? The weight of the object in air. Here is what I'm trying to say. If you come to this question, they said a copper cube weighs 0.25 Newton in air and 0.17 Newtons when completely immersed in paraffin oil. Okay, so we can conclude that the weight of the objects in air is equal to the ruptures in paraffin oil plus the weight of the objects in paraffin oil. Okay, now what is the next step? We are going to solve for the ruptures because they want us to calculate the ratio of the ruptures in a different word now, medium. That is, what is the ratio of ruptures in oil to ruptures in what now? In water. Hence, we are going to be having ruptures, okay, in paraffin oil will be equal to weight in air minus the weight in what now? Paraffin oil. Okay, so we are going to have ruptures will be equal to, okay, what is the weight in air? The weight in air was given us 0.25 Newtons, right? Minus what is the weight when completely immersed in paraffin oil? 0.12. 0.17 rather, okay, in Newtons. And that is equal to, now what is the answer when we subtract this to borrow one here becomes 15. 15 minus 7, that's 8. So we're going to be left with 0.08 Newtons. Okay, now ladies and gentlemen, this is the ruptures force that is acting on that copper cube when you place it inside of what now? Paraffin oil. Okay, now how about when you place it in water? Similarly, using the same equation, when you place it in water, you're going to get ruptures in water instead of Q, we're now having W. Okay, it is equal to the weight in air minus what now? The weight in what now? Water. Okay, this is the second formula. That is, this one will also work for water. The same rule applies. Hence, we're going to be having ruptures in water is equal to weight in air is 0. What now? 25 Newtons minus what is the weight when completely immersed in water? 0.15. Okay, and 0.15 when completely immersed in water. Okay, we have 0.15 Newtons. And that is equal to, now when you take the difference between these two, you should be having 0.1 Newton. Okay, 0.1 Newton. What is the final statement of the question? Okay, the ratio of ruptures in oil to ruptures in water is what? Okay, so the question wants us to calculate the ratio of ruptures in oil, okay, price paraffin oil, to ruptures in what now? In water. And that will be equal to ruptures in oil, that is in paraffin, will be equal to 0.08 ratio, ruptures in water 0.1. Okay, let's do the math. That will be 0.08 over 0.1. When you move the decimal 1, 2, you're going to have 8 times 10 to the power of minus 2 over, move it twice, 1, 2. You're going to have 10 times 10 to the power of minus 2, right? This cancels this, so I'm left with 2 here is 4, 2 here is 5, so I'm left with 4 over 5. Okay, hence the ratio of the ruptures in paraffin to the ruptures in water will be equal to 4:5. That is 4 over 5. Very, very easy. And that gives us option what now? Option B, 4:5. Very, very easy. Okay. Now you notice that this one took quite some time to solve because I was explaining. So if you have practiced lots of questions like this, it becomes easy while you are in the JAMB examination hall. That's because you are not explaining to anybody. Okay, you are just solving, and to be faster if you have done this thing several times, you don't have to think. Okay, that's much to get the right answer. Now we're going to continue solving the other problems. But if at this point you have not subscribed to this YouTube channel, you should do that. So go straight to clicking on the YouTube subscribe button on our channel. Okay, hit that button and also click on the notification bell so that when a new video is being uploaded, not just in physics or in your JAMB other subject combinations, you get notified about it. Okay, after you have done that, you can now come back in joining us to solve this other question. Okay, now question 2 reads: a wheel and axle is used to raise a load of 500 newtons by the application of an effort of 250 newtons. Okay, now if the radii of the wheel and axle are 0.4 centimeter and 0.1 centimeter respectively, the efficiency of the machine is 20%, 40%, 50, 60. Okay, what is the answer to this question? Now this one is another JAMB question on machines. Okay, now how do you solve a problem like this? Now first is first, I would like us to bring out the parameter. Okay, what are the parameters that are given to us in the question? Okay, now it says a wheel and axle is used to raise a load of 500 newtons. Okay, now this is the force or the load. So we're going to come here and we're going to say load is equal to 500 newtons. Okay, now by the application of an effort of 250 newtons, which means effort E is equal to 250 what now newtons. Okay, now if the radii of the wheel and axle, okay, now the wheel's radii, that is the radius of the wheel, is always bigger than the radius of the axle. Take note. Okay, so if the radii of the wheel and axle are 0.4 centimeter and 0.1 centimeter, which means the wheel has what now 0.4, the axle has what now 0.1, and we're going to use a big letter to indicate it. Okay, so the radii or the radius rather of the wheel is equal to 0.4 centimeter and the radius of the axle is 0.1 centimeter. Okay, now what's the next step? We want us to calculate the efficiency. Now what's the formula for efficiency? Efficiency is always work output over work input times 100%. Okay, now we can as well make use of another formula for calculating efficiency. Okay, now that formula is mechanical advantage over velocity ratio. Okay, so the formula for calculating efficiency, okay, efficiency is equal to mechanical advantage over velocity ratio, okay, times 100 what now percent, because efficiency is usually measured in what now percentage. But before we use this formula, we need to know mechanical advantage and we need to know velocity ratio. Okay, now what is mechanical advantage? Mechanical advantage is equal to load over effort. That's the formula, load over effort. Now what's the load given in the question? We have 500 divided by what's the effort? We have 250. Now 500 divided by 250, that gives us what now 2. Okay, it has no units. Take note. Okay, now what's the next thing? What will be velocity ratio? Let's solve velocity ratio. Now take note, velocity ratio is always what now? Big R over small r. Big R over small r. Take note, that is for a wheel and axle system, which means the velocity ratio is calculated by dividing the bigger radius, which is the radius of the wheel, so the radius of the what now? Of the axle. Okay, that is big R over small r, and that will be equal to 0.4 centimeter divided by 0.1. Okay, and that will be equal to what now? 4. No units as well. What is now the efficiency? Now to solve for the efficiency, we're going to have efficiency is equal to mechanical advantage is what now? Just solve this to be what? 2. So that will be 2 over velocity ratio is what now? 4. Okay, times 100 what now? Percent. Okay, so efficiency will be equal to 2 here is 1, 2 here is what now? 2. 2 here 1, 2 here is what now? 50. So we're going to be left with what now? 50%. Very, very easy. And that gives us option what now? Option C. Notice how these questions are becoming easy by solving them. That's because by now you should have understood the concept of these things. And then what you are going to be doing is practicing these questions with me. Okay, they become what now? Very, very easy. Now make sure you practice all of these things because, like I said, they are likely to come out in this year's JAMB examination. Okay, let's now move on to the next set of questions. Now, the next question on the board, question 3, it reads: which of the following is the correct shape of a spherical steel ball dropped into a viscous fluid in a tall cylinder? Okay, now they are asking us to pick which of the options is going to indicate the graph, okay, of velocity plotted against time when a steel ball is dropped into a viscous fluid. Okay, now we know that when we drop an object into a fluid, okay, it will start moving downward. Okay, which of the graph is going to indicate the graph of velocity plotted against what now? Time. Let's analyze. Now take note. When an object starts to fall in a viscous fluid, there is not just objects acting on that object, but there's also what we call the viscous force, just like friction. Okay, if I should start gliding this marker on this board, there will be frictional force acting in the opposite direction in which I glide it. Same thing, okay, in a viscous fluid, if I should drop the object inside, there will be a viscous force acting in the opposite direction. Okay, now when it reaches terminal velocity, okay, the velocity becomes constant. Okay, but before it reaches terminal velocity, immediately it is dropped inside, it starts to accelerate. That is, if it starts to accelerate, the graph should be going like this. That is what now? Acceleration. Now as it starts to accelerate, after some time when it's what now? Attains terminal velocity, okay, it becomes what now? Constant. Okay, the graph now starts moving in this direction. So when you combine these two graphs together, what you get is this. Okay, so at a very small interval, it will start to what now? Accelerate. And after some time, it attains what now? Terminal velocity becomes what now? A graph like this. That is, start going towards the right. That is why we're having a graph like this. So take note. Whenever a body is dropped in a viscous fluid, okay, this is the kind of graph that we are going to what now? Have. Take note of that. Now, how about the next one? Here is the next question on the board. It's with the hydrostatic blood pressure difference, okay, between the head and the feet of a boy standing straight is 1.65 times 10 to the power 4 newtons per meter. Let's look at the parameters again, okay? So in this case, we're having pressure as what? 1.65 times 10 to the power of 4. We have 1.65 times 10 to the power of 4 newtons per meter squared. Okay, now find the height of the boy. Okay, find the height of the boy, and we're giving density of blood as this guy, and we are giving gravity. Okay, so we are giving density, or we have to find height, and we are giving density of blood, okay, as 1.1 times 10 to the power of 3. We have 1.1 times 10 to the power of 3 kilogram per meter cube. Okay, and then we're having gravity, acceleration to gravity as 10 meters per second what now? Squared. Very, very easy. Now, how do you solve for the height? The next thing your mind should go to is which formula connects all of these four parameters together. Okay, which formula connects them? Now, there's a formula that gives us the relationship between pressure, okay, and it is equal to density, okay, times gravity times what now? Height. Okay, pressure is equal to density times gravity times height, and we have to find height. So from here, height will be equal to pressure divided by density times what now? Gravity. Now what is the pressure? The pressure is 1.65 times 10 to the power of 4, okay, divided by what's the gravity? What's the density? We have 1.1 times 10 to the power of 3 times what's gravity? Gravity is what now? 10. Okay, now this gives us 1.65 times 10 to the power of 4 divided by 1.1 times 10 to the power of 4. Okay, 3 and 1 here gives us 4. So this guy cancels this guy. We're not going to be left with h is equal to 1.65 divided by 1.1. And when you divide this, what do you get? Okay, when you divide these two guys, what do you get? Let's make use of our calculator. So I'm going to have 1.65 divided by 1.1. That'll give us 1.5. Okay, so our answer becomes what now? 1.5 meters. Very, very easy. And that is option C. Okay, very, very easy. Now, without wasting much time, let's move on to the next set of questions. So the next question on the board reads, a body weighing 80 newtons stands in an elevator that is about to move. The force exerted by the floor on the body as the elevator moves upward with an acceleration of 5 meters per second squared is. Now, this is a very important question, and you should understand the concept before trying to solve it. Okay, now let's say we're having an elevator like this, and we're having a body, okay, inside of it. If the elevator is not moving, okay, it means we're going to be having a normal reaction force acting on the person. But immediately the elevator starts moving, okay, it means the normal reaction force is going to what now? Start increasing. Why? The elevator has started to move. That is, it is what now? Accelerating, right? When it is accelerating, normal reaction is going to what now? Start to increase. Okay, so initially there's a normal reaction force acting on this person, and as the elevator starts going up, normal reaction what now? Increases. What do you mean by the normal reaction increases? It's not something I want you guys to cram. Okay, for the normal reaction to increase, it simply means the force that the elevator is now exerting on the person's leg has now begun to what now increase. Okay, the person starts to what now feel heavy. Okay, that is because the normal reaction is what now increasing. Okay, now to solve for this normal reaction, we make use of the formula. Normal reaction is equal to the weight of the body plus the mass times what now acceleration. Okay, the weight of the body plus the mass times acceleration. Here is the whole concept. Understand it. Okay, normal reaction force on this person, okay, is equal to the weight of the person plus the person's mass times the acceleration of the what now, the elevator. Okay, and so we can now say normal reaction is equal to m in bracket w plus m in bracket g plus what now a, simply because w is what now, w is equal to what now, mg. Okay, so if we factor out m, we are left with what now, g plus a. From here we can now calculate normal reaction, and it is equal to what is the mass, what is the mass of the body. Okay, we don't know the mass, but using this formula we can make use of the mass, or instead of opening the bracket we can just work directly. Okay, let's use the formula here. So r is equal to what is the weight, we're having 80 newtons. Okay, plus what is the mass, mass is weight over acceleration into gravity, right? Mass is what now, weight over g, okay, times a. So r is equal to 80 plus weight again is 80 over g is what now, 10 times acceleration is what now, 5. So you have 0 cancel 0. We have r is equal to 80 plus 8 times 5 is 40, and 80 plus 40, that gives you what now, 120 newtons. And that is option C. Very, very correct. Okay. Now the next one on the board with, if the distance between two suspended masses 10 kg each is tripled, the gravitational force of attraction between them is reduced by. Now this question is already telling us that after increasing the distance, the gravitational force reduce, but they're asking by how much does this reduce. Okay, now this question is based on Newton's law of gravitational force. Okay, now for that you need to take note that the formula is giving us F is equal to g m1 m2 over r squared, right? Over r squared, where F is the force of attraction between mass m1 and m2, r is the distance, and g is what now, a constant. Okay, now you can say that F is inversely proportional to r squared. So we can say from here that F is inversely proportional to what now, r squared. Okay, now in the question they said if the distance between the two suspended masses 10 kg, it doesn't matter if they give you the mass. Okay, as far as they did not change the value of the masses, okay, the masses remains the same. Okay, we can also say that F is inversely proportional to r squared. Now I'll solve this thing the normal way, but I'll also give you an insight on how you can pick the answer even without solving for a question like this. Okay, for me, remember variation in maths, so you have F1, okay, times r1 squared is equal to F2 times r2 squared. Some of you might not understand this part, especially for those persons offering biology and not offering maths. Okay, in variation, learn variation, there's inverse variation, there's direct variation. Those two are the most common that you make use of. Okay, F is inversely proportional to r squared. From here, you can bring in a constant. You have F equals to Q over R squared, because multiply. You have F1 R1 squared equals F2 R2 squared. Okay, that's mathematics. So you should understand this part. I'm not supposed to be teaching math inside of physics. Okay, so from here, the question says again, if the distance between two suspended masses, okay, is tripled. Okay, so let's say for example, F1, the initial force is what now? F1. Okay, while the initial distance is what now? R1. Okay, then they want us to find the new force F2. Okay, and the distance R2 is triple, that is 3 times R1. So you have what now? Equals 3 times R1. Put into the formula, we're going to have F1 R1 squared equals F2, which you are looking for, times R2 now becomes what? 3R1, right? All squared. We have F1 R1 squared, okay, equals F2 times 3 squared is what? 9. Times what now? R1 squared. R1 squared cancels R1 squared. From here, F2 is equal to F1 divided by what now? 9. So this same thing as F2 equals what now? 1/9 of what now? F. So it means that what now? The new force is what? Reduced by what? 1/9 of what now? F. And that is option what? Option D. Very, very correct. Let's say you are in an exam condition, okay, and you come across a problem like this. How can you solve it without using this short method, without using this solution? Okay, now anytime distance is increased for two bodies that are placed apart, you can see that F is inversely proportional to R, which means if R increase, F is going to reduce. If F increase, R is going to what now? Reduce. They are always opposites of each other. So first things first, we are going to know that If we increase the distance, f is going to what now? Reduce. But if we decrease the distance, f is going to what now? Increase. Now in this case, they tripled it, which means we already know that they tripled the force. That they increased the force. We already know that. Or rather, they tripled the distance. Okay, they tripled the distance out, right? That is, they increased the distance. So we already know that f is going to reduce. That is why they already came here and they told you, they give you an expo that is reduced by, okay, that's an insight. And then again, since f is inversely proportional to r squared, if r is increased by 3, f is going to reduce by what now? 3 squared, because there's a square here. And 3 squared is what now? 9. So know that f will reduce by what now? 9. If r is increased by 2, f is going to reduce by what now? 2 squared, that's what now? 4. If r is increased by 5, f is going to reduce by what now? 5 squared, that's 25. So take note of the what now? Of the pattern. Okay, take note of that. So for this case, option what now? D is correct. Next question on the board. If the total force acting on a particle is 0, the linear momentum will, does it increase or what? Okay, now what's the formula for solving linear momentum? Okay, we know that from Newton's law, F is equal to m times what now? Change in velocity over time, right? And what is momentum? Momentum is what now? Mass times velocity. So from here we can have F is equal to change in momentum. Okay, F is equal to change in momentum, okay, over what now? Over time, right? Now they said if the total force acting on a particle is 0, which means F is 0, okay, so we can cross multiply and we say Ft is equal to change in what now? Momentum. Okay, now since F is 0, it means 0 is equal to what now? Change in what now? Momentum, right? Now I'll from here explain it in two ways. Anytime change is equal to 0, it means whatever we're having in that system did not change. Okay, for that reason, it means momentum is constant. So your answer will be what now? Option B will be constant. But let's assume you don't understand what I just said. Okay, you did not understand it. I'm going to try and break this down further. We can also say 0 is equal to, let's say we're having two momentum, initial momentum and final momentum. So let's say we're having two momentum, okay, initial momentum, momentum I, okay, minus momentum what now? F, depending on which one is bigger. From here we can cross multiply. So now what now? Momentum final is equal to momentum initial. Okay, so initial momentum is equal to final momentum, or final momentum is equal to initial momentum anytime force is what now? Equal to 0. For that reason, if it did not change, if initial is equal to final, it means it did not change, right? And something did not change, it means what now? It is constant. That is why our answer is what now? Will be constant. Very, very easy. Okay, now there's another question on the board, question 8. Now question 8 reads, two forces, each of 10 newtons, act towards the north and the other towards the east. The magnitude and the direction of the resultant force are, okay, what's the magnitude and also what's the resultant? From this statement, we are first going to draw the free body diagram. So two forces, each of 10 newtons, acts towards the north and the other one towards the what now? The east. So we're having one acting towards the north. Okay, this is the north, 10 newtons, and another one towards the east, what now? 10 newtons. Okay, now they want us to find the resultant. Okay, now the resultant is always a line drawn from the intersection of the two what now? The two vectors, right? You can watch my video on vectors, on physics, okay, to understand this one very well. Okay, now this is the resultant. Let's call the resultant R. Okay, we're going to trace here. Now, if here is 10 newtons, it also means that what now? Here is 10 newtons, and this is going to be the angle or direction, theta. Using Pythagoras rule, okay, we know that the resultant squared will be equal to what now? The opposite side squared. We have 10 squared plus adjacent side squared, 10 squared. So R squared is equal to 10 squared is 100 plus 100, and that equals 200. Okay, from here R squared is equal to 200. Okay, which means R is equal to square root of 200. Now if you're familiar with salt, you can break this down. This is square root of what now? 2 times what now? 100, right? So R is equal to square root of 100. If you still don't know about salt, watch my video on salt, still on the YouTube channel. Okay, now square root of 100 is what now? 10. So you have 10 times square root of what now? 2. So our answer is what now? 10 root 2. That is what now for the resultant force. How about the direction? This is the direction, theta. Now we can get this guy by considering any of the sides. Let's make it easy. Let's get the direction by considering 10 and what now? And 10, right? Opposite and adjacent. Make use of what now? Tangent. So we know that tan theta is equal to opposite over adjacent. I shouldn't be writing this because as a JAMB you should already know about this. Okay, so we can say tan theta because what's the opposite? The side facing the angle. So you have 10 over what now? 10. So you have tan theta is equal to what now? 1. So theta is equal to tan inverse of what now? 1. And theta is what now? 45 degrees. Notice how this angle is being made with the what now? With the what? With the east. This is the east. Okay, it is being made with the east. Okay, so we have 45 degrees what now? East. We can also say the angle, if you get the angle here, this whole place is 90. 90 minus 45. So this is also 45, right? So even if the question says the angle is 45 degrees north, why? There's also an angle here and the resultant is making with the what now? With the north. Both of them are correct. And that is why you are not seeing it in the option. Okay, check for the option. There's nothing like 45 degrees north because both of them are correct. Okay, depending on anyone you want. So you can even put it in three cardinals bearing. Okay, so anyone is correct. In this case, we're having 45 degrees east for 10 with what now? 2 newtons in the option. And that is option C. Okay, option C, very, very easy. Next question on the board with a particle in circular motion performs 30 oscillations in 6 seconds. Okay, its angular velocity is what? Angular velocity. Now it is important that you know what angular velocity means. Okay, angular velocity also known as angular frequency. Okay, angular velocity is also known as angular frequency, and the various formulas include angular velocity is equal to what now? V over r. That's linear velocity divided by what now? Radius. Okay, or angular velocity is equal to what now? 2 pi f. Okay, now basically angular velocity is actually the linear velocity that is converted into what now? Its angular form by multiplying it by what now? 2 pi. That's 360 degrees. Okay, basically we are putting the normal frequency we know in radians. Okay, that's what we're doing. That's what we call angular frequency or angular velocity. Take note of that. Now from here we can also say angular velocity is equal to 2 pi times f is what now? N over t, right? Number of oscillations in a given time, right? Now in this case we are giving what now? Time. We're giving oscillation, so we can plug it directly into the test formula. I'm making use of this formula. Okay, so angular velocity is equal to 2 pi times n is what? N is 30 and the time is 60. So you have 30 over 6 times is 6 rather, not 60. So W is equal to 2 pi times 6 here is 1, 6 here is 5 times 5. So W is equal to 2 times 5. That's what now? 10 pi radians per second. Okay, that will be option D. Okay, very, very easy. So basically, now this one is on a part of physics that will come out your JAMB examination, and it's circular motion. I have also taught circular motion. Okay, I've taught all of these things. So always go to my YouTube channel to watch more of them. Okay, now next on the board with the effects of a particle rather. Okay, the effects of a particle in a fluid attaining terminal velocity is the acceleration is maximum. Okay, weight is equal to retarding force. Buoyancy force is equal to viscous retarding force. Buoyancy force is more than weight of the fluid. Now to understand these concepts, I've explained when a particle attains terminal velocity, right? When it is dropped into a viscous fluid. Now take note, when a particle is dropped into a viscous fluid, since it is viscous, we don't only get an obtuse force. Remember, if I should place this marker in water, there will be an obtuse force. I will not mention viscous. Why? Water is having the least amounts of viscosity. Okay, that's how I don't usually consider it. But for other fluids, we are always considering its viscosity, right? Now, viscosity is also a retarding force. Okay, now if we're having a system like this and we drop an object into it, there'll be a viscous force that will be opposing, that is frictional force in fluid. Okay, remember, if this marker is gliding on the board, there'll be a what now? A frictional force opposing it in the direction in which I what now? Glide it. Okay, why for a fluid, the frictional force is now what we call what now? A viscous force. Okay, and that is what speaks about the term viscosity. Okay, now if it is dropped into this fluid, there'll be a viscous force acting upward. And remember, there's also obtuse, right? Obtuse also what now? Act upward. Why the weight of the body will be what now? Pulling it down. And we're going to have the weight of the body pulling it down. Now, let's see the question again. The question is the effect of a particle in a fluid attaining terminal velocity. Terminal velocity. Now take note, when a particle attains terminal velocity, okay, when a particle attains terminal velocity, it means the velocity is constant at that point. It is not accelerating. The velocity is constant at that point. It is not accelerating. Okay, it is moving at a what now? A constant velocity. And for that reason, the weight will be equal to the sum of the two opposing force. The weight will be equal to what now? The sum of the two opposing force. And that will be equal to V plus what now? U. Here U is what now? Obtuse or buoyancy. Take note, if you don't call it uptrust, you call it what now? Buoyancy. Because I know many of you will be confused. What is buoyancy force? Because I've seen buoyancy in the option. Or you'll be mistaking buoyancy for what now? Viscosity. Okay? The weight is now what now? Balancing the what now? The viscous force and the what now? The uptrust force. Okay? So which of the option? Option A is saying acceleration is maximum. That's wrong. Weight is equal to retarding force. Now, what is the retarding force? The retarding force is both the viscous force and the what now? And the uptrust force. And that is what equals the what now? The weight when it attains terminal velocity. So that is option what now? Option B. Okay, if you check for the other options, option C, buoyancy force is equal to viscous force. They're trying to say these two, they are equal. They're even in the same direction. So how are they equal? Okay. Now, option D, buoyancy force is more than the weight of the fluid. They are saying buoyancy force, that this one is more than what? The weight of the fluid. We don't even care about the weight of the fluid. That's another thing. Okay. So option D is already out. Now, that is how problems like this are being tackled. This is what now? Question 10. Okay. Let's now move on to the next set of questions. All right. So over here we have question 11 on the board. Now, question 11 reads: diagram above shows the force F acting on an object through a distance x. The work done on this object is expressed by F times x in joules, Fx over 2 in joules, Fx squared in joules, and F over x in joules. Okay. Now take note. Whenever a force versus extension or a force versus distance graph is plotted, okay, our work done is always the area under the graph. Now, in this case, we're having the shape of the graph to be a triangle, right? Now, the area of a triangle, okay, the area in this case is equal to the work done, okay, and what is area of a triangle? It is 1 over 2 base times height, right? The base in this case is what now? X. Times the height is what now? F. Okay, so that is what now? Fx over 2 or half Fx in joules. That is simply what now? Option B. Now take note, depending on the shape of the graph we get, we determine the area that is being produced or the work done. Okay, if it is a semicircle, it becomes what now? Half the area of a circle. If it forms a square or a rectangle, it becomes what now? Length times breadth or height times width or thereabout. Okay, now here we have the next question on the board. It says a coin is placed below a regular glass block of thickness 9 cm and refractive index 1.5. Okay, I'm going to draw this one on the board. Okay, solution. We're having a glass block like this. Okay, and then a coin is placed beneath it. Okay, this is the glass block, and then a coin is placed beneath the glass block. And then they said the thickness of the glass block is 9 cm and the refractive index is 1.5. Okay, so we're going to have refractive index is equal to 1.5 and thickness, that is from top to bottom, okay, it is what? 9 cm. Okay, the thickness is 9 cm. And then it is viewed vertically upward above the block. The coin is viewed vertically upward above the block. So let's say there is an eye like this. Okay, viewing the coin vertically upward, that is above the block. And then the next question they're asking, the apparent displacement of the coin is, what is the apparent displacement? Now, before you attempt this question, you first need to know the meaning of apparent displacement. Okay, now apparent displacement is what I'm going to explain using this diagram. Now we're having a glass block like this. The thickness is the real depth. Okay, the depth of the height of the block. Now take note, there is a difference between depth and height. We're talking about depth. It means we're measuring from the top to bottom. So from here to here, we call it what now? Depth, looking down. But in terms of height, to measure it from bottom to what now? Top. Take note of it so that you don't make mistakes. Because most persons are going to measure this one from bottom to top and are most likely to make mistakes or encounter errors in terms of measuring stuff like this. Okay, so the real depth, okay, which we are going to call R, is what now? The thickness. So real depth is equal to what now? 9 cm. The question wants us to find apparent displacement. Now there's also what we call apparent depth. Now due to the fact that this medium has changed, it's no longer air, the distance we are going to be viewing from the top to this coin will no longer be 9 cm. The coin will appear what now? Raised. That's why if you place an object inside of water, for example, and look at it from the top, it will appear what now? Closer to you. It has what now? Displaced due to the change in medium and the refractive index. Okay, in this case, let us now say we look at the coin inside of the what now? The glass block, and the coin appears to be what now? Lifted slightly upward. Okay, so let's say the actual depth is here. After looking at it and placing inside the glass block, we notice that the depth is now what now? Somewhere here. Okay, the depth is now somewhere what now? Here. what do we call the apparent depth? The apparent depth is now the distance we're going to measure from here to here. We're going to call that apparent depth D. Now, there's a formula that connects refractive index, real depth, and apparent depth. Now, take note. That formula is refractive index is equal to real depth divided by what now? The apparent depth. That is the formula. Okay. Now, from here, we can now calculate what now? The apparent depth, right? That is the imaginary distance that we see. That is between our eyesight and the coin. So from here, we're going to have D is equal to R over N, right? Now, real depth is 9 and refractive index is 1.5. Now, when you divide this to what do you get in centimeters? Why? Because this guy is centimeters. Okay. Now, when you divide this to what do you get in centimeters? That will be 6 if I'm not mistaken. That will be 6 centimeters now, right? So we're going to have 6 centimeters. Let's confirm. This is 9 over 3 times 2. 3 here is 1, 3 here is 2. So that's 6 centimeters. Now from there, we now want to find the apparent displacement according to the question. Look at the question. The question said, find the apparent displacement. Now, apparent displacement is by how much is the coin raised off the bottom. Okay, this is the actual depth. And when we look at this from the glass block, we notice a depth like this. So by how much was it raised from the bottom? So from this distance to this distance is what we call what now? Apparent displacement. Now check. How do we get the apparent displacement? Looking at the glass block, you don't have to cram it. The total length or the total depth is what now? 9. And then from here to here is what now? We just calculated it to be 6. So what will be here to here is simply what now? The total one minus what now? Here to here. Isn't it? Hence, we're now going to have apparent depth is equal to real depth minus what now? Sorry, apparent displacement rather is real depth minus apparent depth. And that will be equal to 9 minus 6, which gives us 3 centimeters. Very, very easy. Okay, let's proceed to the next question. The next question is, the radiator of a motor car is cooled by what? Okay, now take note. The radiator is designed in such a way that it cools the engine block, okay, by the use of a fluid, usually an antifreeze mixed with water. Okay, now for the chemistry students, you should be familiar with the particular antifreeze we use in that is used in creating the chemical, okay, or the antifreeze or the components rather, or the antifreeze we use in cooling an engine. Okay, if you know the answer, drop it in the comment section. Okay, that's a chemistry question. It usually comes out in JAMB as well. Okay, now the question is, the radiator of a motor car is cooled by what? Radiation, conduction, convection, and radiation. Okay, first is first, you need to know the difference between these various cooling methods. Okay, now radiation has to do with a form of electromagnetism. There's no contact. Okay, example, how the sun reaches the earth. Okay, it's through what now? Radiation. Now conduction, there needs to be physical contact. Okay, usually solids and liquids, or solids and gas and all of that, but they just have to be what now? Contact. And then for convection, it usually occurs in fluids. Okay, now take note, we make use of a fluid like what now? Antifreeze mixed with water in terms of cooling the engine. Okay, this is the radiator, and that is why the answer is what now? Convection. Okay, convection is the answer. So option what now? C. Now, don't think I said convection is the answer, because I just explained convection as a method in which the radiator cools the engine. But this question is saying the radiator of a motor car is cooled by, okay, you that is cooling another object. How do you get cooled? That's the question. Okay, this marker helps to cool this other marker. Okay, if this marker helps to cool this marker, how then is this marker cooled? Because as it is trying to cool this guy, it's getting hot, right? How does this what now cool this guy? It also cools itself by what now? Convection. That is why I pick convection as the answer. So it is cooling the engine by convection. That is a heat exchange process. And it's also cooling itself by what now? Convection. How does it cool itself by convection? Now, there is a fan that is placed in the engine that helps to cool what now? The radiator. So as the fan blows air directly to the radiator then what now? Cools itself. So that means by which it is blowing air is what now? A conventional process. Take note of it. Now, in some advanced books or some advanced examinations, they will include radiation. Do you know why? If you notice the color of a radiator, it's usually black. Okay, now the reason why they paint is black is because black helps to release heat from a body easily, and that is a form of what now? Radiation. Okay, so sometimes they might ask you, okay, in a standard question, how is a radiator cooled? Okay, or how does a radiator cool itself? It is through convection and what now? Radiation. But for the sake of JAMB examination, please pick convection as your answer. Okay, now the next question on the board with, temperature, density of temperature, density of air molecule, pressure and pitch. Which of the above will affect the velocity of sound in air? Now take note, the velocity of sound in air varies with temperature and what now? And density of the molecules. Now when we talk about the density of the molecules, if the molecules are stacked together, sound will not easily penetrate through. Remember, the speed of sound is constant, okay, regardless of the pitch and pressure. That is why it does not depend on these two. These two are already out of it, okay, regardless of the pitch or the pressure, okay, it is always constant, roughly 340 meters per second. Okay, now the speed of the velocity or speed of sound varies depending on the density of molecules. Like I was saying, if it is a cool air, the molecules are packed together. That becomes what now? Denser. A cool air is what now? Denser. Okay, or a colder air is what now? Denser. Hence, sounds cannot easily pass through. Okay, now the other case is for temperature, the reverse case. The hotter the air, the wider the molecules move apart, and then sound can easily pass. So take note that the speed of sound varies directly as what now? The temperature, actually the scale of temperature. Okay, and then what now? Inversely as the density of what now? Air molecules. Okay, so it varies depending on the what now? The temperature and the what now? The density. So which option carries temperature? And there's obviously option A. First option you are seeing there. Okay, very, very easy. Now what's the next question? The next question is, which of the following is a characteristics of stationary waves? They are formed by two identical waves traveling in opposite direction. This one gives the definition of stationary waves. When a wave hits an obstacle and it bounces back, they interact, okay, to produce most times even a stronger wave. Okay, that is, this option A gives us the definition of a stationary wave. But let's check the other options. Okay, let's just mark it and check the other options. For the other options, they said they can be transverse or longitudinal. No. Okay, now the distance between two successive crests is one wavelength. That's also wrong. Go and draw the graph, you see it. Okay, you can watch my videos on waves to understand these ones better. And then the antinode is a point of minimum displacement, also wrong. Like I said, watch my videos on wave to understand these things better. Very, very easy. So now we've dealt with 50 questions. Let's now see the next set of questions. Now the next question on the board, question 16, it is to produce an enlarged and erect image with a concave mirror, the objects must be positioned dash as the principal focus beyond the center of curvature, between the principal focus and the center of curvature, between the principal focus and the pole. Okay, now first things first, we are going to draw a concave mirror. Okay, now this is the reflective surface, this point is the pole. Okay, let's call here the principal focus and here the center of curvature. Okay, now what we are going to do is try putting the objects at different points, okay, along this axis, and see if it will give us this property of the image. But imagine you're in an exam condition. Okay, you can't be doing that. Okay, I'm going to have another video still on this video. I have another video where I've talked about the whole lessons concerning production of images on concave, convex mirrors and lenses. After this video, do it to check it out, still on my YouTube playlist. Okay, now I already know that the answer is option D, between the principal focus and the pole, simply because I have done this thing several times, so I'm used to it. The same way, after watching my videos, you get used to it and you will be able to answer this question with ease. Now, if I should place the object here, this is the object. We make use of the what now? The properties of light rays, right? Now, when one ray passes through like this, okay, once it hits the concave mirror, it reflects back through the principal focus. Okay, reflects back through the principal focus. So this is the incident, this is the reflected ray. Okay, now we can trace this one. Okay, we can trace the reflected ray out of the concave mirror. And then we'll use another property again. Okay, if the light travels through the object and hits this pole, it will reflect back the same way. Okay, so if it comes like this, this thing has to be straight. If it comes like this, okay, it's going to reflect back the same way. Okay, now we can now trace this guy, and we'll notice that it's what now intersects this other reflected ray. Now an image will be formed here. This image is imaginary. Notice that this image form is bigger than this one. See the object, see the image. Okay, this one is bigger than this one, meaning it is enlarged. It is standing upright. It is still facing up, meaning it is what now? Upright. Okay, and because it is on the other side of the mirror, it means it is what now? Virtual. Okay, so it is what now? Virtual, erect, and it is what now? Enlarged. Okay, three properties whenever it is placed between poles and F. Okay, there are other properties. When place it at F, when place it at the pole, when place it at C, when place it between F and C, when place it beyond C. Okay, all of these things you can learn them from my other video. Okay, after this video, like I said, on optics, go to my page and check out the videos to learn more. Okay, now that is for that. So option D is the correct answer. Now for the next question, the property that is propagated in a traveling wave is where frequency, amplitude, energy, and wavelength. Now, from the definition of a wave, what is a wave? A wave is simply a disturbance that travels through a medium, okay, carrying energy without causing permanent displacement of the medium. Now, carrying what? I did not say frequency, neither did I say amplitude. I said carrying what? Energy. And that is what a wave does. It carries what now? Energy. Now, look at these options. Okay, the question is property that is propagated in a wave is propagated means it is carrying what? Okay, what is being transferred? That is the what now? The energy. And that is simply what now? Option C. Okay, option C, energy. Now, what's the next question? Question 18. Which of the following eye defects can be corrected using a cylindrical lens? Okay, there are various kinds of eye defects, okay, that we have. Okay, now this particular one wants us to identify the eye defect that we can make use of a cylindrical lens to correct. We have myopia, we have astigmatism, we have presbyopia, we have chromatic aberration. Now there are lots more. We have hypermetropia, we have strabismus, we have lots of eye defects. Now in this case, they want us to identify the option that can be corrected using a cylindrical lens. Okay, if you want to attempt this one, you can pause the video and drop your answers in the comment section. Once I don't play the video to see the right answer. I don't think I've asked you guys a question since. Okay, so I think you should attempt question 18. So pause the video, write out the option. Okay, number 18, write it out in the comment section. Okay, let's see how we are prepared for the exam. Now, for this one, the right answer is astigmatism. Okay, now astigmatism is a kind of eye defect in which the eye cornea is shaped in such a way that it is like a rugby ball. Okay, if you don't know what a rugby ball is, you can look it up on the internet. A rugby ball is kind of oval in shape. Okay, now that rugby ball, the eye cornea is not shaped in that form. For that reason, any light that passes through the cornea, okay, or the lens of the eye, it does not converge fully on the retina. Okay, it becomes scattered so that some will not be converged in the retina. For that reason, it produces a blurry vision. Okay, and it can be corrected using what now? A cylindrical lens. Now the other option here is a myopia. Now myopia is also known as short-sightedness. Okay, now this happens when the eyeball is too long, hence light will converge in front of the eyeball. Okay, now we can correct the myopia eye defects using a concave lens. And the opposite of myopia is hypermetropia, also known as what now? Long-sightedness. It is due to what now? Shortness of the eyeball, hence light rays converge at the back of the retina. Okay, for that reason, the person cannot see near. Okay, the person can only see far. That is, you have to take whatever you're looking at far away from the person's eyesight before the person will be able to what now? See it. Okay, and it can be corrected using the opposite what now? A convex lens. Now we now also have presbyopia. Now presbyopia usually occurs in old people due to age most times. Okay, it is due to the weakness of the ciliary muscles. That is, these ciliary muscles are unable to what now? Expand and contract freely. Okay, because of what now? Old age or any other reason. Okay, now the presbyopia eye defect is corrected using a bifocal lens. Okay, that's what we make use of. And then for option D, we have chromatic aberration. Now chromatic aberration is when the lens is not so perfect, and for that reason it does not reflect all the colors of light. Okay, it now reflects some, okay, carrying a particular wavelength. It reflects only some. Okay, now all of these eye defects are also talked about in details in my other video. Okay, check my video still on my YouTube playlist where I have discussed the various eye defects, how to correct them, and how they occur or how you can prevent them. Okay, very easy. So for this particular one, option what now? B is correct. Now the next question on the board, question 19. The time rate of loss of heat by a body is proportional to the what now? The difference in temperature. Now this thing actually has a formula. Okay, the time rate of loss of heat, dq over dt, is equal to constant k in brackets, okay, change in temperature over L. Okay, this guy is also called temperature gradient. Now this is actually called the Newton's law of cooling effect. That is, the rate of heat loss, okay, is equal to what now? The change in temperature between a body that is losing the heat and its what now? Is surrounding. Okay, I have area, I have length, and k is what now? the constant. Okay, so looking at the options, difference in temperature between body and surrounding, obviously option A. Okay, so that's straight to the point, option A. Next question, if the tension is maintained on a stress string of length 0.6 meter such that its fundamental frequency of 220 Hz is excited, determine the velocity of transverse wave in the string. Okay, we already know that wave in the string is transverse. Okay, now by having a string like this, for us to produce a transverse wave or a stationary wave, we need to have the string tied between 2 points. Okay, now when you plug this string, when you excite it, you are going to get a wave like this. A wave like this. Okay, now from here to here gives you the length of the string, right? But when you pluck it, how many wavelengths do you get here? You get half a wavelength, right? Remember, wavelength is distance between three consecutive nodes, right? Or antinodes. Now here is a node here. Here is a node here. Okay, now distance between two nodes is what now? Wavelength over 2, right? So have the length is equal to wavelength over 2. Hence, wavelength is equal to 2L. Now the question wants us to calculate velocity. You know that velocity is equal to what now? Frequency times lambda, right? So velocity is equal to what now? Frequency times lambda, where lambda is the wavelength. Hence, we're now having V is equal to F times lambda is what now? 2L. So V is equal to, frequency was given as 220 times 2 times L. What's the wave? What's the length of the string? 0.6. 0.6. So when you do the math, what do you get? We have 220 times 2 times 0.6. That's 264 meters per second. Okay, that should be option B. 264 meters per second. Very, very easy. Okay, and you can learn more on this one still on one of my videos. These ones are just likely examination questions this year, and you must practice them. Okay, now we have another question on the board. A concave mirror of radius of curvature 40 centimeter forms a real image twice as large as the object. The object distance is, okay, now the object distance will be what? First things first, let's look at the parameters for us to solve. The concave mirror is having a radius of what now? 40 centimeter. So radius is what now? 40 centimeter. Okay, and then it says twice as large. Now twice as large simply means the image is what now? Magnified. This is bigger than the object, just like that one we did there. Okay, it is bigger than the object. Okay, and that twice as large means magnification is equal to 2. We have what now? Magnification is equal to what now? 2. He wants us to do what? Calculate the object distance. So what is the object distance? Object distance is u. Okay, now I'm going to make use of the formulas for calculating object distance, image distance, magnification, and all of that. Okay, now which of the formula are we going to use? I don't think there's one formula that connects all this theory. Okay, so what you might want to do is solve for something and then solve for the other one. First things first, we need focal length. Okay, we need the focal length. Now, looking at this diagram, for example, here is F. Okay, now radius of the curvature is actually twice of the principal focus. Okay, the radius of the curvature is the point on this axis. Okay, where this guy is going to form a complete sphere. That is, if we should close this sphere like this, you should pass through what now? The radius of curvature. Okay, and half of it is what now? F. Okay, so take note of the formula that radius of the curvature is equal to what now? Twice F. Okay, so from here we're going to have F is equal to R over 2. Okay, so F is equal to, what's the value of R? That's 40 over 2, which gives you what now? 20. Next thing, we know that 1 over F equals 1 over V plus 1 over U. Okay, and also magnification is equal to what now? V over U. Okay, now what's the magnification? Magnification was given as 2, so we have 2, M here is 2, is equal to V, we don't know, and then U, we don't know as well. So from here, V is equal to what now? 2U. Let's substitute this formula. So we have 1 over F. F we calculated as 20 is equal to 1 over, anyway we see V, we are going to put 2U. So we have 2U plus 1 over U. From here, let's do the maths. Okay, once we do the maths here, I'm going to have 1 over 20 is equal to, factorize that 1 over U. 1 over U in brackets. 1 over 2 plus what now? 1. We have 1 over 20 is equal to 1 over U in brackets. And when you do the math, half plus 1, that's 1.5. Okay, so you have 1.5. From here, let's solve for U. So you have 1 over 20 is equal to 1.5 over U. Okay, hence U will be equal to 20 times 1.5. Now 20 times 1.5, what will be your answer? That should be 30 centimeters. Okay, that should be which option? Option B. Very, very easy. Okay, so that is how a problem like this is being solved. There's always more to learn. This is what now question 21. Let's take the next set of questions. All right, now the next question on the board, question 22 reads, water is a poor thermometric liquid because it's, now when we say water is a poor thermometric liquid, it means if we are to make use of water in thermometry, that is in calibrating a thermometer, okay, or if we are using water as a liquid in a thermometer, what are we going to observe, or why don't we use it? Okay, that's what this whole question is talking about. Option A, because it is opaque. Option B, because it is a poor conductor. Option C, it's waste glass. Option D, has low vapor pressure. And the correct answer is because it's waste glass. Okay, now we use mercury rather than water in terms of thermometry, okay, to calibrate the thermometer, simply because water waste glass. So if, for example, we're having a glass like this, okay, in a tube, and we put water inside, you notice if the water is to move through the tube, okay, if it was there initially, okay, and after heat was applied or heat was removed, it goes below it, there will still be some water at the body, okay, so we cannot use it to calibrate it. Why? Because if these guys will have various readings, okay, these tubes will have various readings, if the water falls below the initial level and it comes there, there will still be some water at the body, okay, on the body of the tube. That is why we don't make use of water. So otherwise we make use of mercury. Okay, now if mercury is to fall below its initial level, there will be nothing left at the body because it does not waste glass. Okay, water wastes glass. So you understand the reason why water is not being used. Okay, now the next question reads, a ray of light which strikes a glass slab from air at normal incidence passes through the slab, okay, undeviated and undisplaced at lower speed, deviated and undisplaced, okay, at lower speeds, and then deviated and undisplaced at lower speeds, blah blah blah, undeviated and displaced at faster speed. Okay, now it is important for you to understand the concepts of when a light ray passes through a different medium. In this case, it's moving from what now? Air to a glass slab. Okay, let's say this is the glass slab. Okay, normally if the light ray hits the glass slab, we know that a normal is being formed, right? And this is the incident angle, a normal is being formed. Okay, now what will happen is, as it moves through different medium, glass is optically denser than what now? Air. Okay, that is, there is more restriction to waves. Okay, they are not free to move just like when they are in air. Okay, for that reason, it's going to what now? Bend like this. This is what we notice. We notice that the light is going to what now? Bend. This becomes what now? The refracted angle. Let's call it Z2. Okay, that's what always happens. This also be its initial part, right? A straight part. But it's what now? Bends. Okay, that's what happens. So it means it's what now? Deviating. This the normal part is supposed to follow. So it's what now? Deviating away from the normal. Okay, just like you can use an instance of when you're at home, you've not got into a higher institution. Okay, your parents give you strict rules, so you have to obey. Okay, now you are not that free to move. Now, when you're now going to the university, okay, you are free to move. Your parents are not watching always. You know what now? Deviate away from the normal rules they gave you. That's what's happening here. So you can use that concept to remember. Very, very easy. Okay, so it deviates away from the normal. Okay, that's what happens here. But in this case, notice the question. Oh, notice what the question is saying. A ray of light which strikes a glass slab from air at normal incidence. At normal incidence. You are going to take note of this particular term, is normal incidence, which means there is no angle like this in this case. We're now having a scenario like this at normal incidence. Okay, it means it is just on the normal like this, no angle. On the normal like this, no angle. That's what they are saying. Okay, now if it is passing it on the normal like this, what do you think is going to happen? It is going to what now? Pass through directly. It's going to pass through directly. It will be what now? Undeviated. It's still going through the same path. Okay, it will be what now? Undeviated. Also undisplaced. That's what you take note of. Okay, look at the difference. There's also a third case. That's why we'll have what we call our total internal. Oh my god. Make sure you are watching my videos on optics. So there's also another case which we call total internal reflection. JAMB will also ask you that. So we have case 1 where you're having a normal angle. Case 2, it is what now? Placed on the normal, directly opposite. And now another one. It should not be placed like this. Okay, like this. This is the normal. Okay, when you tilt the light ray, it now lies perpendicular to the normal. In that case, we now have what now? What we call total internal reflection.
Watch my other videos and understand these concepts very well. Okay, so for this particular question, option A is the answer. Undeviated, okay, undisplaced, and at a lower speed. Now take note, as far as it moves from air to glass or from air to water, as far as the medium is denser than the one it is coming from, the speed must be what now? Be reduced. Take note, when a light ray moves from an optically less dense medium to a denser medium, okay, the speed is always what now? Reduced. Okay, you can use the same concept. Glass and water, they are somehow thicker than air, right? So the speed of light in water and in air, they are no longer what now? 3 times 10 to the power 8. They are now what now? Less than 3 times 10 to the power 8. Okay, very, very easy. So option A is the right answer. Take note of that. On the next one, blowing air over a liquid aids evaporation, okay, by increasing its surface area, decreasing its vapor pressure, increasing temperature, decreasing density. Now the actual answer is by decreasing its vapor pressure. Let me explain. First is first, let's say we're having a liquid like this, a hot liquid. Okay, what is vapor pressure? Vapor pressure is actually the pressure that the air, okay, around a liquid exerts on it. Okay, vapor pressure is that pressure, okay, that the air that is just at the surface of a liquid exerts on it. Okay, that's the pressure. Now this vapor pressure is actually varies with temperature. That is, as the temperature increases, vapor pressure what now increases. Now how does blowing air over the liquid now affect the pressure, and at the same time aids evaporation? That is, it helps the liquid to cool faster and remove the hot airs. Okay, now these gases, they are just around the surface. When we now blow air, on these gases that is on this surface, it scatters this vapor that is on top, this one. And what this vapor was doing initially, they were preventing the vapor, the hot vapor inside of the liquid from escaping freely. Not like they're not escaping, no, but because of this hot air that is just around this, okay, creating an external pressure, it is what I'm preventing the vapor in this liquid from escaping. That's what it does. Okay, so as we blow air, it scatters it. And once it scatters it, some of these ones are going to escape quickly, freely. Okay, and then they cannot return back. So that's what happens. Okay, when blow air, it is what now going to reduce the vapor pressure. It's going to what now? Reduce the vapor pressure, right? And as it reduces the vapor pressure, some of the gases what now escape. Hence, temperature what now drops. Very, very easy. So that is option what now? Option B. Blowing air over a liquid aids evaporation, okay? By what? Decreasing its vapor pressure. JAMB is going to ask you. Take note. Next one on the board, question 25. The phenomenon that makes sound persist when its source has been removed, okay, is known as what? Reverberation. Okay, reverberation is what we call that. Okay, that is the phenomenon that makes sound persist when the source has been moved. Now take note, there's a difference between reverberation and echo. Take note, there's a difference between reverberation and echo. In fact, look for it by yourself. Okay, source for it. What's the difference between, or let me just tell you guys now, reverberation is actually faster. Example, let me give you guys an example. In terms of when lightning strikes, okay, there's one loud sound we hear that occurs. Okay, that's reverberation. While echo, when you make a sound in an empty room, for example, you hear your voice back. Okay, so reverberation is always more. It is where the sound overlaps multiple ones. While for echo, just few ones. Okay, and echo actually has a more useful. Echo is actually more useful than reverberation. Example, you can use echo to determine distance. You can also check my page to check for videos where I've solved problems on sounds. Okay, use echo to determine what now? Distance. While for reverberation, I'll give you an example as well. Okay, now for this particular phenomenon, take note to it comes out most times under wave. The phenomenon that makes sound persist. Don't go and choose echo. This is what now? Reverberation. Okay, to learn more about all of these other options, check my videos on wave. Okay, now question 26. The pressure of 3 moles of an ideal gas at temperature 27 degrees Celsius having a volume of 10 to the power of minus 3 m cubed is, you want us to solve for the what now? For the pressure. Now there's a formula for solving for this. There's a formula for solving for this. And the formula is pressure times volume is equal to what now? Number of mole times RT. Okay, now we are asked to solve for the pressure. So from here, pressure is equal to nRT over V. So P is equal to what's the number of mole N given as 3. Now molar gas constant varies depending on the units. In this case, it is 8.3. It was not given in the question, but trust me, JAMB should give you. Although there are sometimes they don't give you constant, though. That's why you have to be acquainted with these things. Times the temperature. And this temperature should be in Kelvin. That will be 27 degrees Celsius plus 270, right? So 270 plus 27 degrees Celsius. Okay, now we add that, you should get 300 there, divided by the volume. And what's the volume? 10 to the power of minus 3. 10 to the power of what now? Minus 3. Hence, P is equal to, now when you solve for that, using your calculator, what you're going to get is option D. Option D is 7.47, okay, times 10 to the power of 6 newtons per meter squared. Very, very easy. Okay, practice more problems with me, you will get acquainted with all of these process. Okay, now question 27. Question 27 is vibration in a straight string can be polarized because they are. Now, in the actual JAMB pack where I sourced for this particular question that is likely to come out, what was there was cannot be polarized, and they also failed it. Luckily for you, you have me. Okay, I'm giving you guys the correct one now. The correct question should be vibration in a straight string can be polarized. Why? Because vibration in a string can actually be polarized. That is, it can be made to vibrate in a single plane, such that the direction in which you propagate the wave is perpendicular to the what now? To the plane. Okay? They can actually be polarized, but the question was not saying it cannot be polarized, and they also answered it. Now, what is the reason why they can be polarized? That is because they are transverse what now? Waves. Take note. Waves that are transverse can be polarized. In fact, only waves that are transverse are waves that can be what now? Polarized. Example, waves in a string. Okay, vibrating in a string, whether it's a guitar or any musical instrument. Okay, other examples, electromagnetic waves. Another example, when you drop an object into a pool of water, there are ripples that are being formed. Those ripples are also what now? Transverse wave, and they can be polarized. Take note to transverse wave can be polarized, or in fact, only transverse wave can be polarized. But the answer to this particular one, I think they said it was longitudinal or it cannot be polarized. That's completely wrong. Okay, so don't take note of all the answers that have been answered in the past questions, because most of them are what now? Wrong. Okay, so vibrations in a straight string can be polarized because they are what now? Transverse waves. Take note, they are transverse waves as well. Okay, now to see it, the colors seen in a soap bubble, in soap bubbles, okay, are due to what now? They are due to dispersion. Okay, I think I have a video on dispersion of what now? Light as well. You can also check my video on that. Dispersion of light. Okay, that's the reason for it. And then question 29. Question 29 is calculate the refractive index of the material for the glass prism in the diagram above. Also, I have a video on this. Okay, refraction through glass prism. I think that video, it did well. Many students enjoyed it, so you might as well want to watch that one if you really need to pass your examination or understand the whole concept. I broke down the formulas and how to understand the reason behind all of this. Okay, but in this case, I'm just going to give you the formula. So if you need more explanation on it, maybe you've not learned it before, you have to watch that video. Okay, now I'm going to go straight to solving this problem using the formula. Okay, now I want to calculate the refractive index. Refractive index, according to Snell's law, is sine the angle of incidence, okay, divided by sine the angle of what now? Refraction, right? We already know that. And this can also be sine the angle of deviation over 2 plus apex angle over 2 divided by sine the angle of what now? Refraction. And sine the angle of what now? Refraction is also the apex angle over 2. So we have a over 2. Now let's solve for this. Okay, so we have the refractive index is equal to sine, in brackets, what's the deviated angle? That's 30 degrees. Okay, so you have 30 over 2 plus a over 2, that's 60 over 2. Okay, divided by sine of 60 over 2. Now when you do the math, you get refractive index of 2 here is 30, 2 here is 15. So that will be sine 45 divided by sine 30. And what is sine 45? Okay, that's why you should always offer math as well. What's sine 45? Now sine 45 is root 2 over 2, right? So we're going to have root 2 over 2 all over sine 30 is 1 over 2. Okay, so we're going to have root 2 over 2 times what now? 2 over 1. 2 cancels 2, so you're left with what now? Root 2. That will be option what? Option C. C is always correct. C for Christ. Okay, so that is how problems like this have been tackled. This is question 29. Let's now move on to the next set of questions. All right, for question 30, we're having a circuit on the board, and the question reads, from the diagram above, determine the value of resistance X. That is, we have to solve for this resistance. We are given a current that is flowing through the whole circuit, and then the voltage, and then some certain resistors. Okay, now I know what many persons will do is to calculate the total resistance there, and then you have some sort of expression that has X in it, then use it to solve. I think that's quite cumbersome. Why not solve for the total resistance by using these two, and then subtract these two, then subtract the other one that is left? Okay, let's do that. That's the easiest and fastest way to solve the problem like this. Okay, you can always get used to these methods by practicing multiple examples. Okay, so first is first, let's get the total resistance. Okay, so V is equal to I times R. Okay, solution. You know that V is equal to I times R. So we can get the total resistance as what now? V over I. Okay, what is V? V is giving us 12 volts in the question, and then I is giving us 2. So that's what now? 6 ohms. Okay, now looking at this arrangement, this one, they are in series with everything here. Okay, so the total resistance is equal to 2 ohms plus 1.5 ohms plus these ones, they're in what now? They're in parallel and they're in series with everything here. So we're going to put this in bracket. That will be, let's call everything here, let's call everything, what do we call it now? Let's call it, let's call it unknown, K. So the total resistance here, we are calling it what now? K. Okay, so from here, total resistance we got was 6. So we have 6 is equal to 2 plus 1.5 plus what now? K. Okay, so K is equal to 6 minus 2, that's 4. 4 minus 1.5, that's what now? 2.5. Okay, so the total resistance here is 2.5. And the total resistance here. The reason I had to put K was, I know some people will make mistakes. They will think, okay, this one is in parallel. So let's put 1 over 3 plus 1 over x here. Let's put 1 over 3 plus 1 over x here. If you do it like that, it will be wrong. Why? Because this 6 here is not 1 over 6. Because everything here needs to be reciprocal. Okay, now if you don't understand what I'm trying to say, just follow the normal method. You avoid making mistakes. Okay, so we have what now? K as 2.5. So from there, everything here is what now? In parallel. So the total resistance which you got at 2.5 will be in parallel with this guy, right? So that will be 1 over 2.5 is equal to 1 over 3 plus what now? 1 over x. Look at the reason why I was saying that guy should be in brackets, or we should replace it with K instead of this guy here. That's because as soon as you put this one here, what would have been having here will be equal to 2.5, and our answer will be wrong. You understand? Okay, so that's why we're having 1 over 2.5 equals 1 over 3 plus 1 over x. So not to say I used to the system, don't rush to solve problems like this. Okay, so from here we have 1 over x is equal to 1 over 2.5 minus 1 over 3. Okay, 1 over 2.5 minus 1 over 3. When you do the math, what do you get? So you have 1 over x equals, this now becomes 1 over 5 over 2 minus 1 over 3. So 1 over x is equal to 2 over 5 minus 1 over 3. Okay, let's do the math. We have 1 over x is equal to, LCM is what now? 15. This 3 times 2, that's what now? 6 minus, this is 5 times 1, that's what now? 5. We have 1 over x is equal to 1 over 15. Plus multiply, you have x is equal to what now? 15 ohms. Okay, that's option what now? Option D, very, very easy. Next question, question 31. The energy stored in a capacitor of capacitance 10 microfarad carrying a charge of 100 microcoulombs is, okay, what is the energy stored? First of all, you need to know the formula for calculating energy stored in a capacitor. Okay, there are the various formula. Energy is equal to 1 over 2 QV or CV squared, or energy is equal to 1 over 2. Now know that C equals QV, right? C equals QV. So another formula could be, if you put C is equal to QV, so from here Q is equal to what now? C over V. Put it in this formula. Rather, and the next question on the board with the energy stored in a capacitor of capacitance 10 microfarads carrying a charge of 100 microcoulombs is, now before you can solve for the energy, you need to know the formula for calculating energy stored in the capacitor. Okay, and that's 1 over 2 QV or 1 over 2 CV squared. Okay, or remember that Q equals CV. Okay, Q equals CV. So from this formula, V is equal to Q over C. Let's put it into this equation. So I have E is equal to 1 over 2 Q squared over C. Okay, very, very easy. I think that's the last formula. That's last formula is what we need actually. Okay, because in this question, we are giving volts and we are giving, no, we are giving charge. We're giving capacitance rather, and then we're giving charge, right? Capacitance and charge. Now let's solve directly. So E is equal to 1 over 2 times q squared. This is the charge 100 microcoulombs. We have 100 micro is 10 to the power of minus 6, okay, all squared, divided by 10 microcoulombs. 10 times 10 to the power of what now? Minus 6, okay. And when you do the math for that, what do you get? Okay, when you do the math for that, you should be having option D, okay. 5 times 10 to the power of minus 4 joules. 5 times 10 to the power of minus 4 joules, okay. Very, very easy. 5 times 10 to the power of what now? Minus 4 joules. That's how a problem like this is being tackled. Now, the next one on the board, when connected to a mains of 250 volts, a fuse rating in the plug of an electric device of 1 kilowatt is, they want us to find current. They are giving us power and they are giving us volts. So you need to know the formula that connects power and volts. Okay, now the formulas of power: P is equal to IV, okay, or I squared R, okay, or V squared over R. Now we are giving power, we are giving volts, and we are asked to calculate what now? Current. Okay, so we are going to make use of what? If we are giving power, we are giving volts, we have to calculate current. So we mix of this what now? This first one. So current is equal to what now? Power over volt. What's the power? The power given there is 1 kilowatt hour. We have to convert it to what now? Watts. So 1 kilowatt hour, kilo is what now? 1000. We have 1000 divided by, the volt is what now? 250. Okay, 250 here is 1, 250 here is 4. We have what now? 4 amps or 4 amperes. Okay, that's option C. Okay, next question. The eye controls the amount of light reaching the retina by adjusting what? Now, this one is a very popular question in terms of optics, okay? I also have a video where I taught the eye and optics, so ensure you watch the video, okay? Now, the correct answer is the iris. The iris. Now, take note, the iris is actually not a structure, okay? It is an opening, it is the aperture of the eye, and it is being controlled by the ciliary muscles, okay? It's either expands or contracts, okay? So, to create the size of the iris. That's what the ciliary muscle does. It expands or contracts. So that opening, that aperture we have there, it's like the window of the eye. And you can also call it the window of the eye. That space, okay, is what determines the amount of light that goes into your eye or comes out. Not the eyelid, though. In case you see an eyelid, the option, don't pick it as the answer. Okay, so the correct answer is what now? In the iris. Now, the next question we are going to talk about is question 34. An electric iron is rated 1000 watts, okay, 230 volts. What is the resistance of the element? We're still using the same formula. In this case, we are giving power 1000 watts and we are giving 230 volts as V. We want to calculate what now? R. So from here, we're having P is equal to what now? V squared over R. This is the formula we're going to use. So from here, we're looking for R. R is equal to what now? V squared over P. So R is equal to 230 squared. 230 squared over P is what now? 1000. Okay, now when you do the math again, what do you get? You get option B, 52.9. Okay, 52.9 ohms. Very, very easy. Okay, you just have to know the formula. Okay, I also have a video talking about electricity. You need to learn more of this. Okay, now looking at question 35, we're having a diagram here. The question is, the electric field between 2 point charges is shown in the diagram above. What is the type of charge? What type of charges are at X and Y? Now you have to analyze. Now you should know that for positive charges, the electric flux are always directed outward. While for negative charges, they are directed inward. So for this one, they are directed outward. This means this one is positive. For this one, they are directed outward. It means positive. Now when they are placed together, since they are what now? Like charges, they have to what now? Repair. That is why you notice that the electric fields are directed outward when they are placed together. Okay, that's what happens. This means X is positive, Y is positive. Okay, so which option has that? Both X and Y have to be positive. That's option what now? Option B. These questions are even too easy. Next one, question 36. The electromagnetic wave that can produce a heating effect on the environment is, it is obviously infrared wave. Now that's why we actually have infrared cameras. Okay. Now infrared, whenever you see infrared, just know it has to do with heat. Okay. Infrared rays can produce heating effects. Okay. Heating effects. If you need a visual explanation, you can go on the net and search. Okay. Visual explanations of an infrared ray. You should see some samples. Okay. It's usually used in the night vision or in cameras. Okay. Very, very correct. Now this is number 36. Let's solve the next set of questions. All right. Question 27 on the board with an electric cell with terminal voltage E has a resistance of 3 volts, of 3 ohms rather, connected across it. If the voltage falls to 0.6 E, the internal resistance of the cell is, okay. Now they said with terminal voltage. Take note. They said the terminal voltage is what now? E. Okay. So for an electric cell, the terminal voltage is E, okay, and it later falls to 0.6 E. Okay, it later falls to 0.6 E. Now, this E is the EMF, remember? So they are using EMF as a form of describing the terminal voltage. That's 0.6 of E. Okay? Now, if the voltage later falls to 0.6 of E, the internal resistance is, so you have to find the internal resistance, right? And we're giving the external resistance as what? We're giving the external resistance as 3 ohms. We're giving the external resistance as 3 ohms. Now, from Ohm's law, we know V is equal to IR, right? V is equal to IR. From here, we can make I the subject, and I will be equal to V over R. Okay, so according to this parameter given, we're going to have I is equal to 0.6 E over R is 3. Okay, and when you divide this, what are you going to get? You're going to get I equals 0.6 divided by 3. That will be 0.2 E. Okay, now also we know that EMF is equal to I in bracket external resistance plus internal resistance. Okay, so I is equal to EMF divided by external resistance plus internal resistance. Okay, so if we plug in R, we're going to have I equals EMF divided by big R is 3 plus small r. Okay, now let's equate these two together. Okay, they both have I. We're going to have 0.2 E equals E divided by 3 plus R. Okay, E cancels E. So I'm left with 0.2 in brackets 3 plus R equals what now? 1. Okay, from here, R is equal to 1 divided by 0.2 minus 3. Okay, so R will be equal to, now 1 divided by 0.2, what are you going to get? Okay, this same thing as 2 over 10, so that's 10 over 2. So that's 5 minus 3, and that's equal to what now? 2 ohms. Okay, that is obviously option B. Very, very correct. Okay, that is how a problem like this is being tackled. Okay, the question reads again: an electric cell with terminal voltage E, okay, has the resistance of 3 ohms connected across it. If the voltage falls to 0.6, okay, now don't make the mistakes of substituting 0.6 E for the new EMF. No, it is the terminal voltage that is being talked about. So anytime you're replacing it, regardless of the method you're taking, you always equate 0.6 E to what now? V, which is what now? The terminal voltage. Okay, now the next question is Na reacts with X, okay, according to this reaction. What particle is X? Now, this one is a radioactive reaction. Okay, now to get the value of X, or to identify the value of to identify what X is, we need to get the values on top and below first, right? Now I'm going to sum all the numbers on the left and equate it to all the numbers on the right. Now let's call here A and let's call here B. So sum all the numbers on the left for the top part. We're going to have 23 plus A, okay, we're going to have 23 plus A is equal to 20 plus 4. Okay, 20 plus 4. From here, A is equal to 20 plus 4 minus 23, and that will be equal to what? 1, right? Now, how about the bottom? I'm going to have 11 plus B is equal to 9 plus 2. Okay, so we're going to have B is equal to 9 plus 2 minus 11, and that will be equal to 0. Now, which radioactive substance has a form of 0 at the bottom and 1 at the top? That's simply what now? Neutrons, right? Neutrons have mass of what now? 1, and what now? Charge of what now? 0. And that is option what now? Option C. Very, very easy. Okay, now next one is on AC circuit. We're having an inductor connected to a resistor. Okay, now which of the following graph shows the correct vector diagram for the circuit? Okay, we're having, for the circuit above, we're having various diagrams. Now take note, for an inductor, the voltage of an inductor will always lead the current by what now? Pi over 2 or 90 degrees. Okay, now that is if the voltage is facing up. Okay, if the voltage is going up like this, the current should be what now? Like this, to show you that there's a phase difference of what now? 90 degrees. Okay, that's how it is. So in this case, we're having what now? VL facing up, obviously option B. Now, if it was a capacitor, the voltage lags the current by what now? 90 degrees. So this guy will be facing down. Okay, and then there will be current along this side and then voltage down, just like this one. Current along this side, voltage down. So if this was VC and this is a capacitor, then it would have been what now? Correct. Okay, and you can learn more of these things by watching more of my videos on AC circuits, still on my YouTube page. Okay, now question 40, the last one. It's with pure silicon can be converted, okay, to a p-type material by adding a controlled amount of what? A trivalent atom, pentavalent atom, hexavalent atom. Now, There are two types of semiconductors, okay? We have the pure and the impure semiconductors, okay? Pure semiconductors have not been doped. That is, we've not added an impurity to make them more conductive, okay? While impure semiconductors, they've been doped, okay? We call them what now? Extrinsic semiconductors, while the pure ones are called intrinsic semiconductors. Now, under extrinsic semiconductors, we have the p-type, we have the n-type, okay? Now, to form the p-type, we add what now? A trivalent atom, okay? And to form the n-type, we add the what now? A pentavalent atom, okay? In my video on semiconductors, I've explained this. You can also watch that after this one, okay? Now, for this case, for a p-type, take notes, we always add what now? A trivalent what now? Atom. Ladies and gentlemen, these are 40 likely JAMB examination questions on physics that we just tackled. I'm sure you guys enjoyed it and you learned a lot by sticking from the beginning to the end. And it doesn't end there. You still have to practice more, okay? That is why you might want to watch my other videos still on my YouTube page, okay? Where I solve multiple problems, not just in physics, but in your other JAMB subject combinations as well, okay? If you have any more questions, feel free, drop it in the comment section, okay? Remember, you can as well join our online class for JAMB and WAEC, where we teach students all of the JAMB syllabus and the questions that are likely to come out in the exam. So, part of our online classes, all you simply have to do is go to my page, okay, and then click on the link that takes you to my WhatsApp DM. Now, let me know that you want to be registered for our online JAMB and WAEC classes. I'll show you how to do that. If you have any more questions, like I said, drop it in the comment section. I will always respond to you, okay? Don't forget to like this video, share with your friends, and then subscribe to YouTube channel. Click on the notification bell so that when a new video is being uploaded, you'll be one of the first persons that will get notified about it. See you in the next video.